Hello, friends. Today I wanted to tell you about my most recent pet projects. This is something I've been thinking about for a little bit, but I only started a couple days ago. And basically, it's a pure Rust CPU only implementation of an LLM. I picked the recent LFM 2.5 8 billion 1B active model, like specifically the 4-bit Q4KM quantization. Um, and kind of like the idea here is that, well, local models are getting more and more powerful. Like they're actually getting quite capable. I think it's actually pretty impressive what you can do nowadays with just like a 8 billion parameter model. But GPUs are really fucking expensive. So I think there's still like very much a use for models that can run CPU only. I think one particular use case would be if you want to run an LLM on a server, like if you have like a virtual private server for some kind of backend or some kind of automation, uh, like cloud-based servers with GPUs are actually very expensive compared to like a CPU only server. Or if you have like an older machine that you just want to put an LM on for some experiments and you want something that's like reasonably capable and fast, like I think this could actually work for your needs. The other thing is like, yeah, I built this as like a pure Rust crate with like very few dependencies. So this makes it possible to actually like link this LLM like directly into your application. Like the only requirement is like you do need to download the weights, like the gguf file. And you can give it like an environment variable to tell it like where to find this file. Otherwise, like it defaults to the current directory. And that's basically it. Like you can clone this repo, build it, download the weights, and you're ready to go. Uh, I'll give you like a little example. Um, so I built like a little chat interface, and it streams the token. It's a thinking model, so like you can also see like it's thinking tokens. And just for fun, like tell me about Montreal is the city where I'm based. So like I tested it with that just to see like does it produce sensible output? Like how much does it hallucinate? And I think it it does pretty well. Like most of the information seems to be accurate. One thing I will say is like I did ask it about like Montreal restaurants uh twice, and one time it actually output like several real restaurants. The other time it hallucinated some results. Like obviously like uh this doesn't have access to search the web and it's only an AB model. Um, but this LFM model has been specifically trained for like tool use. So apparently it's especially good at that. I actually want to add a feature to be able to register callbacks for some tools so that you can register like a Rust callback and a model can call it and that'll like call a function in your Rust code. But yeah, let me show you. So I have a little like CSV table with some users, and I added like at syntax like in Claude so I can include the file. And the model seems to do pretty well at like simple automation like that, I think. Yeah, so here we go. Still thinking. Ta-da-da. All right. Let's ask it to convert this to JSON. Um, yeah, you can see like it's parallelized, so it's making a pretty good use of my CPU cores. It's using cross-platform SIMD primitives. Like this is a Ryzen machine, So it's got AVX2. So I tried to use like the cross-platform uh, Rust SIMD primitives as much as I could. Um, I've also tested it on a MacBook Air M5, and I'll also use some SIMD primitives there to make it run faster. Okay, yeah. So as you can see, like it's even in like CPU running on CPU only, like I think it's like pretty fast. It's like fast enough to be interactive, and it seems to be definitely good enough for some like simple automation and tool use tasks. So I'm pretty happy about that. So like I said, I implemented this over a couple of days. Like I made heavy use of Cloud Code. Let's be honest. And I when I first made the port, it was getting like 0.89 tokens per second. I did like several rounds of like trying to optimize the kernels and bringing parallelism and SIMD. I created like a little benchmark script where you can specify like here I'm gonna use like 16 threads, and I'm getting like 38 tokens per second on prefill, 33 on the decode. Like for fun, I decided to benchmark Llama to CPP. I was kind of afraid like compared to Llama to CPP, like the performance of my thing is gonna be like humiliatingly bad. Um, Here I'm forcing Llama, like I do have a GPU on this machine, so I'm forcing it like not to use the GPU. Um, and the result is uh, Llama has much faster prefill. Like I think I'm gonna go back and try to optimize the prefill on my implementation. But like the actual like generation tokens per second is actually not far off from what I'm getting. And I think that I have a lot more room left for optimization in my model. Like, there's several more optimizations that I could apply, so I think like I might actually be able to match Llama's throughput. Um, so I'm actually pretty happy with this. Like I think this project is already potentially in a usable state. It's already public on GitHub. Like the URL is like Maxime github.com/maximecp/BebeLM. Um, yeah, so feel free to clone it for kids, play with it, have fun. Feel free to open any issues if you run into any problems. And yeah, I'm also tempted to maybe like release this as a Rust crate. One thing I should mention is like this is designed as a library crate. So it's made so that you can actually import, uh, yeah, into your project, and like I said, like directly link it. Um, One thing that's kind of cool with the API is that you can create one instance of the model, like this is going to store like the weights, and then you can actually create multiple agents that are going to reuse these weights. So like each agent is going to have like its own chat history and its own KV cache. But the weights themselves can be shared between all these agents. So this can actually be like pretty memory efficient if you're running like multiple agents that are doing like multiple different things at the same time. Yeah, like I said, it's missing the tool use right now. But I think it'll be like very easy to implement actually. Um, what else? I did add some like command line options to configure it. You could also configure the agents with like a builder type syntax. Um, One thing I will say is like this is a thinking model, so like if you disable thinking, your results may vary. Like I'll show you just for fun. Um, like here I'm gonna disable thinking. Like this model is not made. It wasn't. It doesn't have an option to disable thinking. So this basically like just shuts it down. Like, as soon as it starts thinking, it's gonna shut it down. You know. Uh, and here it works pretty well, but sometimes it goes really off the rails. Okay, like it's probably not gonna be able to solve this without. Oh, okay, what? All right. Okay, that went like surprisingly way better than I thought. Let's try it again. Yeah, so you can see like this time, like even though I told it like it can't output thinking token, like it just put like slash think directly in its output like as text because it's like it doesn't know it's not made to operate this way. Uh, but I think yeah, you could also limit cap the length of the thinking, and I think that works a little bit better. Uh, yeah, so that's it. This is my new little pet project. I hope that this can be useful for some people. I like I said, I think there's a real use for CPU models, especially because like nowadays you can get virtual private servers for dirt cheap for like a few dollars a month. But GPU servers are way more expensive. So it's definitely use here. And lastly, I guess like I've tested this on both a Ryzen machine with AVX2, like a this is a 7950X. So like it should work on any Intel CPU that has like AVX2. It should work on like the Apple M1 to M5. Like I've tested it on an M5. I think it will also work on a Raspberry Pi 5, maybe a Raspberry Pi 4, but that's completely untested. So if anyone has a Raspberry Pi and they want to test this thing on it, let me know if it works. Like I'd be very curious. Yeah, that's it. Thanks everyone. Have a great day.